Quick one. So, integration. This PowerPoint is about indefinite integration and definite integration. If you don't understand what that means, it's fine. That's what we're going to do. So before I get into all of that, let us just look at your syllabus objectives because I didn't put it in the PowerPoint yet. Can you see that? You see a blank screen. Hold on. Can you see that? No. Hold on. Yes, you can. Okay. So above here is differentiation, right? This whole thing, integration, differentiation, is under introductory calculus, right? So when you're doing calculus, say you decide to do A levels or in university or college, you decide that you want to do some kind of course with calculus. This basics, differentiation, integration, and application would be required for you to, do calculus, right? This is literally the basics of calculus. So integration, differentiation, like I said, they usually come, I wouldn't say as one topic, but they're kind of, intertwined. You need to know about differentiation to fully grasp what integration is. And same with integration, to fully grasp what differentiation is, if you know what I mean, right? So what exactly does the syllabus require you to know? First thing, students should be able to recognize integration as the reverse process of differentiation. That's why I said they're linked. You need to know about differentiation in order to do integration, right? So, yeah, that's why I said if you're confused anytime along the way, just let me know, right? So, anti or anti-derivatives, we'll learn about that just now. Using notation, the integral of f of x dx, that's for indefinite integrals, concept and use. Show that the indefinite integral represents a family of functions which differ by constants. Use simple rules of integration to find integrals of sums and multiples of functions. So there's some rules of integration that you need to know. I'll go through all of them. Integrate functions of the form ax plus or minus b to the power of n, where a, b, n are real and n is not equal to 1. Minus 1. I'll tell you why just now. Why n cannot be equal to minus 1. Integration of polynomials. We'll do that just now. Integrate simple trigonometric functions. Compute definite integrals. Oh, wait. My aim is to finish indefinite integrals today. Definite integrals will be next class, and hopefully application of integration. Okay, so let's start now that you know the syllabus objective. So first you need to know, obviously because we're doing integration, you need to know what integration is. So consider the equation y is equal to 2x squared plus x minus 4. You should know that this is a polynomial, or you might refer to it as a quadratic. The quadratic is a polynomial to the second degree, right? We talked about that when we did polynomial. So consider the equation y is equal to 2x squared plus x minus 4. If you were to differentiate, then dy on dx is equal to 4x squared plus 1. Like I said, I really wish you told me that you didn't do differentiation, because then I would have done that today instead of started integration. So this is kind of a problem. This is a problem. Because I don't know what differentiation is. Who's the other person in my class? Not Josh, not Louise. Jana, is that how you pronounce your name? How?
Yes.
Did you yet? Well, differentiation. Did you do differentiation yet?
Yeah, I know about it.
Before, I won't get into the differentiation thing. Let me just focus on integration. I'm telling you, so when you differentiate this equation, you're going to get 4x squared plus 1, right? And let me just show you the differentiation real quick. So differentiation, how do we differentiate? So say I have an equation y is equal to ax to the n. How exactly do I differentiate this? Well, there's a rule, and the rule says dy on dx, which is called the gradient function. Like I said, I really wish you told me that you didn't do differentiation yet. I would have done that too. But yeah, it is. So what you do, the rule is you multiply this by the power, so it becomes n by ax.
Good night. Good night.
Right. So you multiply the expression by the power, right? So the power in this case is n. But then you have to subtract 1 from the power. So it becomes n minus 1. Just to, give you context on how exactly that's applied, let me show you an example. Say I have y is equal to 3x squared. I told you that this is my equation, y is equal to 3x squared. And I asked you to find the gradient function, which is dy on dx. Following this rule, what you do, you take the power and you multiply by the expression, right? So 2 is my power, so I'm multiplying 2 by my expression. But then, hold on. This graphic shouldn't be here. Let me put the multiplication sign. Right. So the power is multiplying by the expression, but then you have to subtract 1 from the power. So 2 is my power here. I have to say 2 minus 1 to get 6x. 2 minus 1 is 1, so that's 6x to the power of 1. But we know from indices that anything to the power of 1 is itself. So this would give me 6x. So for the people who've never done differentiation before, just note this rule here, right? Just until I do it with you, because I really didn't know that some people didn't do differentiation. Have you not? Yes, I just got. For the people who didn't do differentiation before, did you write this down? Yes.
Yes, miss.
Rulis, did you write it down?
Yes, miss.
Yes, miss.
So, like I
Miss, I
said,
just neutral, miss.
okay, that's fine. I just started. We didn't really miss anything. So like I said, I wish you told me you didn't do differentiation, because then I would have started that before I did integration. So, like I said, if you were to differentiate this right here, it would become 4x squared plus 1. Okay, now I have to 4x squared plus 1. However, if you were given dy on dx, so instead of them giving you the equation, they gave you the gradient function, and then they asked you to find what. So in this case, they gave you y and asked you to find dy on dx. But what happens if they give you dy on dx and ask you to find y? How would you do that? Well, to find y, you need to apply this rule. If dy on dx is equal to ax dn, then y has to be the integral of that. What exactly is the integral? How do we find the integral? Well, to do that, use this rule right here. Ax to the power of n plus 1. So what does that mean? All you're doing is adding 1 to the power. Whatever power it is, you're adding 1. And then you're dividing that whole thing by the new power, right? but n has to be greater than 1. Or as you saw in the syllabus, n cannot be equal to only 1 now. N has to be greater than -1. Or as we saw in the syllabus, n cannot be equal to -1. You might be wondering why. Well, if I have n plus 1, and n was -1, -1 plus 1 is 0. But you cannot divide by 0. Why? You'll get an, well, that would be considered undefined. If you want to check it out yourself, just put anything in the calculator divided by 0. You will get error. Because anything divided by 0 is undefined. Right? So that's why n has to be greater than -1, or sometimes you might see n cannot be equal to -1. This process of anti-differentiation, so the reverse of differentiation, is called integration. So what is integration? Integration is basically the reverse of differentiation. Ax to the n is called the integrand, and then the integrand is basically what you're integrating, and then the result is called the integral. And the symbol for integration is this little curly thing right here, just like you see here, right? Everybody good so far? Especially my people who didn't do differentiation yet.
Yes, miss.
Yes, no?
Yes, miss. I'm just copying down the formula in the red.
Okay. You just need to copy down this one. Let me know when you're finished.
Miss, I got it. Thank you.
Is anybody still writing?
No, you can move on.
To ask me any questions, right?
Maria, somebody in the chat is calling your name.
Is this, no, I didn't put it yet. There are two different types of integration, right? Like you saw in the syllabus, there's indefinite integration and definite integration. Oh, what exactly are those two types? What do they mean? Okay, so let's look further into that. Indefinite integration. Again, consider an equation y is equal to 3x squared plus x plus c. Notice, in this case, they said plus c, where c is some constant, right? So we don't know the value of c. Unlike before, where we knew that the value of c, which is the constant, was -4. In this case, you don't know the value of c. You just know it's a constant, right? So hence, they said where c is some constant, you don't know the value of c. If you differentiate this expression here, you get 6x plus 1. So you might be wondering, but where did the plus c go? Why didn't I put it here? That's why I said it's important for you to know about differentiation before you start doing integration. And it's because if you differentiate a constant, you're going to get 0. So whatever this constant is, right? It does not matter. -4, 2.5, whatever it is. When you differentiate a constant, you would always get 0. So in reality, what I would get is 6x plus 1 plus 0. But we know the 0 is understood. You don't go put plus 0, right? And that's why they just left it up. And that's where the c went. Because if you differentiate a constant, any constant, you're going to get 0. The 0 is understood. So there's no need for you to put plus 0, right? However, so this is the other case, right? If you're given dy and dx is 6x plus 1. So in this first case, they gave you the equation y and told you to find dy and dx. But here, they gave you dy and dx and they want you to find the equation y. Just like we did just now, you're going to integrate the gradient function. So remember, integration is an anti-differentiation process, so the reverse of differentiation, and that's how you're going to get your equation y. by integrating, doing the reverse, right? Let me just write this because I feel like it would help. So if I'm going from y to dy on dx, so you're going from y to dy on dx. They gave you the equation y, and they want you to find dy on dx. I told you that this process is called differentiation. So just put this, right? However, if I want to go from dy on dx, which is a gradient function, to y, as you can see, this arrow is pointing downwards, right? But this one is going up. Hence, it's the opposite or reverse of differentiation. And this right here is called integration. So if I'm given the gradient function and they want me to find y, I integrate. I do the reverse of differentiation, right? So you follow the rules that I showed you just now. Integral of 6x plus y. Okay, I add 1 to the power and then I divide by that new power. So it's 6x to the power of 1 plus 1 divided by 1 plus 1 plus x to the power of 0 plus 1 divided by 0 plus 1. All right, you simplify to get 6x squared on 2 plus x on 1 to get 3x squared plus x. Before I move on, do you understand how I did this, like this whole process, or would you like me to write it down? Just writing. Do you understand it?
Miss, I
And it's
understand. Good.
Write it.
Yeah, miss, I understand. I understand like the last 3 lines, but the first line I just like I don't understand how you got from the first line to the second line. But I understand the rest after that.
Okay. So they asked me to differentiate the expression. That's my integral sign, right? Differentiate 6x plus 1 with respect to x. So I put the dx. If you want to put this in brackets, right? You need to recall the rule. You see, for integration and differentiation, it's very important for you to know the rules, right? Like, you must know the rules, okay? Like, have to. So this is the rule for integration that I had on the slide. So I said y is equal to the integral of ax to the power of n dx is equal to ax n plus 1 on n plus 1, right? That's what I had, right? Integration. So I see there's a rule we're going to meet just now, right? And it states that if you have two terms, so in this case I have 6x and I have 1, you have to integrate each one individually. So what do I mean by that? You need to find the integral of 6x and you need to find the integral of 1, right? You meet that rule just now. So what do? I said I'm integrating 6x and then I'll integrate 1. So let me integrate 6x. Following my rule, this is 6x. So 6x, it's understood that the power here is 1, right? Because when we did indices, we said anything raised to the power of 1 is itself. So by saying 6x, I'm implying 6x to the power of 1. So that's why I can say 6x to the power of 1, and my integration rule says I must add 1 to that power. So it's 1 plus 1 divided by n, which was the power from before, and we said that it's 1, right? The 1 is understood. So it's 1 plus 1. But I told you that we have to integrate each term individually. It's a rule that we're going to learn about soon, right? So plus, and I'm integrating this individually. Just like I did here, I follow the rule and I integrate 1. So how exactly do I do that? Well, you need to recall from indices anything raised to the power of 0 is 1. So therefore, I can say 1 is the same as saying x to the power of 0. Then I just follow the rule. I have to add 1 to the index. Then it's n, the original power, which was 0, plus 1. If I simplify, 6x, 1 plus 1 is 2, so that's 6x squared. 1 plus 1 is 2, plus 0 plus 1 is 1. So that's x to the power of 1. 0 plus 1 is 1 over 1. Hold on, right? People are joining. Okay. But I don't just leave it like this, right? I can simplify even more. We know whenever you can simplify, you have to continue simplifying, right? You can't just leave it like that. So what will I get here? 3x squared. Anything raised to the power of 1 is itself. So saying x to the power of 1 is the same as saying x. And then anything divided by 1 is also itself. So x divided by 1 is x. Hence, I got this. 3x squared plus x. Do you understand that now? Yes? No?
Miss, this is stuff I'm kind of confused about, miss.
This?
Yep, miss, on the top green one on the right side. Like, how do you find the power? How do you get the power of 0?
You do in the media or exponent. So that's not really, no? Indices, exponent.
Miss, I'm so confused, miss. Like, because normally I would think that it was like 1, like it would be 1, but like, why is it 0?
So I'm guessing you didn't do the topic in the but aka exponent. There's some laws of indices that you need to know. I did it already, right? It's a topic you're required to know for your exam. So there's a law that says, so let me just use x as my base, right? Anything to the power of 1 is itself. So by saying x to the power of 1, this is equal to x. If I say x, which is my base again, raised to the power of 0, anything, according to that law, right? Anything raised to the power of 0 is going to give me 1.
I misunderstand on this.
Yeah. So that's why it's important for you to know all the material, because you never know, right? We're doing integration and look to seeing exponents. That's why it's important for you to know what's going on. Can I take this off now?
Yes, miss.
Yes, miss.
Yes.
There's a problem though. I said integration is the reverse of differentiation. So if I go from this, right, my equation, y is equal to whatever, and I differentiate, I get dy on dx. Integration is the reverse of differentiation. So if I start off with dy on dx, which is 6x plus 1, when I integrate, aka I do the reverse, I'm supposed to get back this equation. Y is equal to 3x squared plus x plus c. But if you look at this equation here, and you look at this equation here, can anybody tell me what's missing?
The C.
That's a problem, because we're supposed to get back this exact equation. So that's why I have here, but this is not the original expression. The original expression is y is equal to 3x squared plus x plus c. This is only giving me y is equal to 3x squared plus x. The constant c is missing and must be added to the result. It must be added because we must get back this equation, okay? So what is this c? C is called an arbitrary constant. So anything in math, when you hear arbitrary, it means it does not have a specific value, or the value is unknown. We don't know the value of the constant c, hence it's called an arbitrary constant. It's a constant, and we don't know the value, so arbitrary constant, right? So we don't know the value of this. The value is unknown unless other information is given. But we're not worrying about that now. You learn about that when we do an application of integration, right? So hence, when I find the integral of 6x plus 1, yes, I get the 3x squared plus x, but I have to make sure I put the plus c. This type of integration, where you see that plus c, this is called indefinite integration. Hence, I showed you the integration rule just now, but for indefinite integration, you must remember to put that plus c. Because remember, without the plus c, I don't get back the exact equation. I have to get back the exact equation. So I have to put that plus c, right? So that's indefinite integration. Wherever you see plus c, indefinite integration. Do you understand? Yes? No? Maybe?
Yes, miss.
Yes, miss.
Josh, Elise, wait, Elise isn't here. Josh, wait, yes, Josh, wait, bro. Curry's best teacher. Do you understand?
Yes, miss, I understand.
Okay. Now let's practice. Integrate the following with respect to x. So would you like me to do the first one with you, or would you like to try it by yourself?
Let's
I'd like
do
to
the
try
first one.
this. Hey, miss, I'd like to try it first, miss.
Okay. Well, I think this will take like